All right, let's say we are looking for a 98% confidence interval for the average difference in IQ scores. For twins, we're doing firstborn minus secondborn. There's a full video that walks through all of these pieces, but I thought I would just show us on the calculator how we do this. So we've got our list of differences. We could have been given all the individual scores for firstborn and secondborn, but here the subtraction's already been done for us. So -3, for example, means that the firstborn minus secondborn was -3. So the secondborn actually had a higher IQ. So any negative number means the secondborn is a higher IQ. Positive number like 8, the next one, means the firstborn had a higher IQ. Anyway, these are all of the differences. So this is basically paired data. So we could go into stat, edit, put those numbers into a list. Now I've already put those into a list. You can just verify there. But anyway, put those into a list, and then we can say, well, we want a confidence interval. So we go to stat, we go over to tests, and then we know the first 6 items on there are all different tests. We actually want an interval though, so we're gonna scroll down a little bit and say, okay, we have all these different interval options. So while we might have started with what looked like 2 samples, but because this is paired data, it actually is a single sample. And because we're looking at average difference, that means 1 prop is out. So all of these 2 sample and 2 prop, those are all out. 1 prop is also out. So that leads us to Z interval and T interval. We know the distinction between those is that we use Z if we have sigma, the population standard deviation. Now that definitely wasn't given to us. It turns out that for T, we need the sample standard deviation. That also technically was not given to us, but because we have a sample, because we have this collection of sample differences, we're going to use a T interval because our list, we could certainly find the sample standard deviation from that. Okay, so we have 2 options input, data or stats. Now we don't have the stats. We could go find those, but instead we have data. We have our data in a list. I had put mine in list 1. If you put yours in a different list, just update this. Frequency, just leave that as 1. And then our confidence level, it just depends on what we want. So here we want a 98% confidence interval. So we'll say 0.98, and then we'll calculate. And then it'll come up with our lower bound and our upper bound. So I'm just going to round this to 8.8. Remember though, if we want any kind of point estimate, well, first of all, we've got X bar, so the average difference is 0.25. So that's provided to us. If we wanted, say, the standard deviation for our list, that's also provided to us. So that 0.25. What that means is that's right in the middle of our interval. Another way to find that, if we wanted to find X bar, we could say, well, let me just add my lower bound to my upper bound and divide by 2, and that should get us our 0.25. So if we're just given an interval like this, we can find the center of it just by averaging the lower bound and upper bound. The other part of this is if we're asked for something like margin of error, well, okay, margin of error is just the distance from the center, so from X bar, to either the lower bound or the upper bound. So we could say, okay, from the upper bound down to the lower bound, what would we have? So if you're not sure, you can, of course, calculate this thing over here. So 8.8 minus 0.25, great. So our margin of error is 8.55. So we don't even need a fancy formula if we already have the interval here. So that's kind of helpful. And if you wanted to verify that it was still the case that it's 8.55 to go from the center, so 0.25 minus negative 8.3. So this one's a little bit more confusing because our lower bound is negative, so we have to do minus a negative, but we would still get 8.55 as well. So we can find all these different pieces just from the interval itself. So from the interval, we were able to find X bar, we were able to find the margin of error. Because we know the standard deviation, we could find our T star value. So there's a lot of things we can find from this.